Good morning, friends. I once again welcome you all for the next session on the first chapter, that is Introduction to Combinational Logic Circuits. So far in the last session, we have seen some special kind of decoders. The next next combinational logic circuits that we are going to study is encoders. The encoders are the digital circuits or are the combinational logic circuits which perform the inverse operation of decoder. So decoder ಏನು ಮಾಡ್ತಿತ್ತು? Decoder system was represented using uh, by annotation n is to 2 to the power of n, means it is going to have n inputs and 2 to the power of n outputs. Andre the information on n input lines was decoded on the information on the 2 to the power of n output lines. But this performs the inverse operation. Encoder this performs the inverse operation in the sense it will have a decoded information on the 2 to the power of n input lines which is encoded on the n output lines. So this is the logic system, or this is the combinational logic circuit system which receives the decoded information on the 2 to the power of n input lines and produces the encoded output on the n output lines. Okay, this is the exact reverse operation of decoder. So an encoder has 2 to the power of n input lines and n output lines, that is the binary information on 2 to the power of n input lines is coded into the binary information on n output lines. So usually in the communication systems, whenever we are doing a data encryption, or whenever we want the security on the data that we are sending from transmitter to receiver, usually the decoder is used at the transmitter end. And so if you want to get the original information back, then the encoder should be must at the receiver end. Then only the original message which was sent by the transmitter will be received correctly at the receiver. So usually the decoder and encoders, they find their applications or they are employed in the communication systems to have the data encryption or to have the data security. So from as we know that in case of decoder, out of 2 to the power of n output lines, only one line was activated at any time. So here in the reverse fashion, out of 2 to the power of n input lines, only one line will be active high or active low, or that is activated. So based on which input line is activated, on that information a coded information is produced on the n output lines. Okay, that is from all input lines only one input line is activated at a time. So 2 to the power of n input lines ನಲ್ಲಿ ಯಾವುದಾದ್ರೂ one ಲೈನ್ ಮಾತ್ರ ಆಕ್ಟಿವೇಟ್ ಇರುತ್ತೆ. ಆ ಯಾವ ಲೈನ್ ಆಕ್ಟಿವೇಟ್ ಇರುತ್ತೋ ಅದನ್ನ ನೋಡಿಕೊಂಡು ಎನ್ಕೋಡೆಡ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಎದರ ಮೇಲೆ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ, n ಔಟ್ಪುಟ್ ಲೈನ್ಸ್ ಮೇಲೆ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. So this is the logic system, or you can say the general block diagram. It will have 2 to the power of n input lines, and this is the decoded information. Decoded information is received on these 2 to the power of n data input lines, and it is encoded, and the result is produced on the n output lines. Again this will have the enable input to either enable this logic system or disable the logic system, and this is how the logic system is represented, that is 2 to the power of n is to n. So by putting different values of n, I can have the different encoders variants here. First we shall see the 4 is to 2 encoder, means if you put the n value equal to 1, then you will get a 2 is to 1 encoder. So that is very similar to the 2 is to 1 demux operation. And if you put n equal to 2, then 2 to the power of 2 means 4 is to 2 encoder. We will see the operation here. A 4 is to 2 encoder will have a 4 input lines and 2 output lines. The decoded information is received on 4 input lines and it is encoded and the result is produced on the 2 output lines. So out of 4 input lines, only one line will be activated at any time. So based on which input line that is activated, depending on that one, a corresponding output pattern will be produced on the 2 output lines. So the same thing is written here. So from 4 input lines, only one input line is activated at any time. Depending on the input line activated, it produces a 2-bit output code, that is encoded output is produced on the 2 output lines. So this is the logic symbol, a 4 is to 2 encoder. So here it has 4 inputs and 2 outputs. You can take an enable signal here, or you can simply omit it. So this is the truth table. You can see here there are 4 input means there will be 4 combinations. So out of these 4 combinations, you can see in all these 4 combinations only one line is activated at any time. So based on which line is activated, the output code is produced. The first combination you can see here, only Y0 is activated. So since Y0 is activated, the output code will be 0 0. You can see the subscript here. Subscript is 0 means its equivalent binary notation will be 0 0. Similarly, in the second case, only Y1 is activated. So Y1 ಮಾತ್ರ ಆಕ್ಟಿವೇಟ್ ಆಗೈತಪ್ಪ ಅಂದ್ರೆ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಏನಾಗುತ್ತೆ Y1 ಇದು 1 ಅಂತ ಇದೆ. So output code will be 0 1. Similarly, in the next case, only Y2 is activated and corresponding output code will be 1 0. And the last one, only Y3 is activated and the corresponding output code is 1 1. It is very simple for us to write the logic expressions for the output, that is for A1 and A0. English statement ಹೇಳ್ತೀನಿ, ಅದು ಅರ್ಥ ಆಗುತ್ತಿಲ್ಲ ನೋಡ್ರಿ. A1 is 1. A1 is 1 whenever Y2 and Y3 are 1. Correct? A1 1 ಎಲ್ಲೆಲ್ಲಿರುತ್ತೆ ನೋಡ್ಬೇಕು ನೀವು. A1 1 ಕಾಂಬಿನೇಷನ್ ಯಾವ ಕಾಂಬಿನೇಷನ್ 1 ಇದೆ? Y2 1 ಇದ್ದಾಗ ಮತ್ತು Y3 1 ಇದ್ದಾಗ. Simply you have to OR it. English statement ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ತೀನಿ. A1 is 1 whenever Y2 is 1 or Y3 is 1. OR ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಪ್ಲಸ್. That is Y2 plus Y3. Similarly for A0. A0 is 1 whenever A0 is 1 whenever Y1 is 1 and Y3 is 1. So that is Y1 is 1 or Y3 is 1. Or ಅಂದಾಗ ಮತ್ತೆ ಏನಾಗುತ್ತೆ? Y3 plus Y1. So these are the two simple logic expressions. So since the literals are ORed here, we have to use the OR gate. So A1 ಅಂದ್ರೆ ನೋಡಬಹುದು ನೀವು. A1 is nothing but 1. You are getting a literal Y3 here and you are getting one more literal Y2 here. This is nothing but Y3 plus Y2. And similarly for this one, Y3 plus Y1. This is for A0. This is the logic circuit. Similarly, if you put a n value equal to 3, we get a 8:3 encoder system. Sometimes it is also referred as octal to binary number system. Octal andre 8 ಅಂತಾಗುತ್ತೆ. 8:3 encoder. So obviously 8:3 ಅಂದಾಗ the number of inputs will be 8. That is from Y0 till Y7. And number of outputs are only 3. A2 till A0. At any time only one input line will be high, active high, and corresponding to the which output line that is high, output encoded data is produced on the output lines, 3 output lines. You can see the truth table here. So for the first combination only Y0 is activated. So for that the binary encoded data will be 0 0 0. Similarly for next one only Y1 is active high, corresponding pattern will 0 0 1. Similarly for the last combination only Y7 is activated At any time only one input is activated, rest all inputs will be 0, which was exactly reverse in case of decoder. Decoder na ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಬಹುದು, ಯಾವುದಾದ್ರೂ ಒಂದು ಔಟ್ಪುಟ್ ಲೈನ್ ಮಾತ್ರ ಆಕ್ಟಿವೇಟೆಡ್ ಇರ್ತಿತ್ತು. ಇಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಇನ್ಪುಟ್ ಲೈನ್ ಮಾತ್ರ ಆಕ್ಟಿವೇಟೆಡ್ ಇರುತ್ತೆ, ಉಳಿದಿದ್ದೆಲ್ಲ ಏನಿರುತ್ತೆ, ಯಾವ್ದು ಆಕ್ಟಿವ್ ಇರುತ್ತೋ ಅದು ಹೈ ಇರುತ್ತೆ, ಉಳಿದಿದ್ದೆಲ್ಲ ಏನಿರುತ್ತೆ 0 ಇರುತ್ತೆ. ಸೊ ಇದು ಬರೆಯೋದು ಹೆಂಗಪ್ಪ, ಈಸಿ ಬೈನರಿ ಪ್ಯಾಟರ್ನ್ ಬರೆಯೋದು ಹೆಂಗಪ್ಪ ಅಂದ್ರೆ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ನೋಡ್ಬೇಕು ನೀವು. ಇಲ್ಲಿ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಅಂದ್ರೆ ಹೆಂಗಪ್ಪ, y0 ಅಂತ ಇದೆ. 0 ಇಸ್ ದ ಡೆಸಿಮಲ್ ನಂಬರ್, ಇದಕ್ಕೆ ಡೆಸಿಮಲ್ ಇಕ್ವಿವೆಲೆಂಟ್ ಬೈನರಿ ಏನಾಗುತ್ತೆ, ಬೈನರಿ ಇಕ್ವಿವೆಲೆಂಟ್ ಆಫ್ ದಿಸ್ 0 ಅಂದ್ರೆ 000. ಸಿಮಿಲರ್ಲಿ ನೋಡ್ರಿ y7 ಅಂತ ಇದೆ. ಇಲ್ಲಿ y7 one last combination 7 is represented in the binary sequence with a binary sequence 111. So this is how the truth table is written. And so as I already told you, uh, the method to write the logic expressions for the output, a2 is 1. a2 ಯಾವ ಕಾಂಬಿನೇಷನ್ 1 ಇದೆ ನೋಡ್ಬೇಕಾಗತ್ತೆ ನೀವು. a2 is 1 whenever y4 is 1 or y5 is 1 or y6 is 1 or y7 is 1. ಅದಕ್ಕೆ y5 plus y6 plus y4, this is the first combination, this is the first expression. Similarly a1 is 1, a1 ಎಲ್ಲೆಲ್ಲಿ 1 ಇದೆ ನೋಡಬೇಕು, for 4 combinations. a1 is 1 whenever y2 is 1 or whenever y3 is 1 or whenever y6 is 1 or whenever y7 is 1. So the same combination is written here. Similarly for a0. So these are the logic expressions for the outputs. Let's see the logic circuit. So this is the logic circuits for 3 outputs. So we need a 4 input OR gate and corresponding signals are connected in this fashion. You can verify it later. Next, this is some special kind of encoder. Generally the standard encoders were represented with the logic system or with annotation 2 is to n, 2 raised to n is to n, or 2 to the power of n is to n. So this is the standard encoder. So as we have seen some special decoder, that is BCD to decimal decoder, this works in the exact reverse way. So that's why decimal to BCD encoder anta ಹೇಳ್ತಾರೆ. So here the BCD to decimal decoder was indicated by the logic system 4 is to 10, means 4 inputs and 10 outputs. This is the decimal to BCD encoder, means the reverse one andre idar artha. So here a decimal to BCD encoder converts each decimal digits, that is from 0 to 9, into a binary code. It accepts 10 inputs and produces a 4-bit output code. Andre decimal to BCD encoder andre this is basically a 10 is to 4 encoder. This 10 is to 4 encoder andre there will be 10 inputs. The decoded information is received on these 10 inputs. Andre out of these 10 inputs only one input will be high at any time. So based on which input is active, on that an output encoded data is produced on the 4 output lines. Okay, this type of encoder has 10 inputs, one for each decimal digit, and 4 outputs corresponding to the BCD code. BCD ಬಗ್ಗೆ ನಾವು ಆಲ್ರೆಡಿ ಡಿಸ್ಕಷನ್ ಮಾಡಿರ್ತೀವಿ, and this is a 10 is to 4 encoder. You can see the logic symbol here. So there are totally 10 inputs are there, that is from D0 to D9, and the outputs are designated with the alphabets, that is Y0 from Y0 till Y3. So you can see the truth table here. So in the first combination only D0 is activated. So corresponding to this D0, the output encoded data is 0000, and we have to consider only the 10 combinations because it is a decimal to BCD encoder is there. So 10 decimal digit indication ಮಾಡಲಿಕ್ಕೆ 10 combinations ಸಾಕು. So last one is D9. The last combination D9 is active high. So 9 ಅಂದಾಗ it is represented with a binary sequence 1001. Now you already know Since there are four outputs are there, there will be four logic expressions. So in order to write the logic expressions, you have to consider the combination for which it is 1. Okay, let's say I want to write the logic expression for y3. Y3 is 1 only for the last two combinations. So y3 in English you can simply say like this: y3 is 1 whenever d8 is 1 or d9 is 1, means d8 plus d9. So the same thing is written here. Similarly for y2 also, y2 is 1 for 1 2 3 4 4 different combinations. ಅದಕ್ಕೆ y2 ನ ಇವು 4 ಕಾಂಬಿನೇಷನ್ ಬರೆದಿರೋದು. Similarly, if you consider y0, y0 is 1 for 1 2 3 4 and 5. Totally for 5 combinations y0 is 1. So these are the boolean expressions for the outputs y0, y1, y2 and y3. And finally, once we get the logic expressions, the next thing is to write the logic circuit for it. So this is how the logic circuit looks like this. So here for implementing y0 we need a 5 input OR gate, and for implementing y1 and y2 expressions we need a 4 input OR gate, and for last one y3 we need a 2 input OR gate. The same thing is drawn here. So we have different variations of OR gate here. For y3 we have a 2 input OR gate. For y2 and y1 we have a 4 input OR gate, and for implementing y0 we have a 5 input OR gate. So this question, either a decimal to BCD or BCD to decimal decoder or decimal to BCD encoder will be asked in your examination for 10 marks. So here the students are expected not to get confused. So while reading the questions, read it properly whether it is asked you to write the encoder or decoder. So based on that one, you have to write the answer correspondingly. So if you do a mistake, decoder ಬದಲಿ encoder ಬರೋದು ಅಥವಾ encoder ಬದಲಿ decoder ಬರೆದ್ರೆ, you will lose all 10 marks and you will get 0. Okay, thank you.